cross-site scripting and some of the layer 7 attacks. We'll try, to not touch on all the same subjects, but we do kind of cover the basics of cross-site scripting. Some advanced cross-site scripting, so you understand the risk and why is this really important. Same thing with SQL injection. We'll talk about the state of web application security, which kind of brings about the need for tools like this. And then more importantly, we introduce the tools. And we show how the tools can be used and where you can get them and what's next for the tools and whatnot.
Okay, so cross-site scripting. Do we care? Is this important? Anyone? Anyone thinks that this is actually important?
Yes.
Yeah.
Anyone think this is insignificant? Just pop-up boxes, who cares? What do you think the worst thing we can do with cross-site scripting is? Steal your personal information, yeah? There was actually a proof of concept released last year for doing scanning of internal networks through JavaScript. So if you can cross-site script someone, you can then scan their internal network and find out where all machines are. Anyone here think I can rob a bank using cross-site scripting?
Yep.
Well, I'm actually using it more than cross-site scripting, but cross-site scripting is the main thing I'm using here. So luckily I have my own. Hey, look at that. So
I don't believe you there.
I'll do this one in video because I've done too many demos and I don't all go wrong. So we're going to cross-site script a bank here. We're going to use some AJAX and some CSRF, cross-site request ordering. But the main thing that lets us do this is cross-site scripting. So IBD Bank, that's the International Branch of Dan Bank, brought to you by the Department of Redundancy Department. So it's a simple bank, lets you sign up, lets you pay people, lets you log in, right? So you can sign in. We're just going to log in. The victim's going to log into the bank here. And anyone that signs into my bank, so I'm a nice guy, he gives him $1,000. So this victim here, he comes in, he's got his $1,000. So he can go to the payment center, and because he likes me, he's going to add me as a payee, and he can pay me back $1 of my $1,000 because it's cheap. So he's just getting caught up because I talk faster than he uses the mouse. But you can see it's a simple app, right? Nothing complicated. This is all fully, it's all Rails, so it's using sessions, and you could do this whole thing over SSL. It wouldn't make a difference. We could do it all. So you can see it's paid him $1. So no big deal. So the next thing we need to do is we're going to look at this app and find a cross-site scripting vulnerability. That one cross-site scripting vulnerability is going to let us do what we want to do. So in this case, we're actually just going to use tamper data, just so we can quickly find the vulnerability. And what we're going to do is we're just going to tamper the data, and we're going to replace the payee name, which is coming in that combo box, with a script alert, cross-site scripted, or XSS. So we're just going to see if we put in an extra value. This is all happening after it's gone through Firefox, so Firefox isn't seeing this. And when it comes back, we have cross-site scripting. So sweet, we got a cross-site scripting vulnerability, okay? So now, we happen to log into the bank, and we go and navigate to somebody else's website. So this does have the requirement that you log into the bank at the same time you go somewhere else. But with things like Facebook, Twitter, it's a lot easier to find out what people are doing these days. So we've got the bank here, and he'll eventually catch up. Apparently I talk really fast. And so he goes over here to the other site, the super interesting, fun things site. So the interesting about this is, in the background, this is actually robbing my bank. You don't see anything. It looks just like you're at a site. What's going on? Nobody knows. But there's actually an iframe that's using AJAX, exploits that cross-site scripting vulnerability, and uses CSRF to rob the bank. Because it's doing it through AJAX, any anti-CSRF tokens aren't going to do anything because we can parse them back out again. It's useless. And look, there goes my $500. And suddenly, I've got another payee on my bank called Hacker. And that's it. You've now just lost $500. And the most annoying thing with that whole thing is, it came from your browser. So it looks like you did it. There's no way to prove somebody else did it. You just went to a website, and then your browser sent all these requests to the bank. And it was that one cross-site scripting vulnerability that let us access the cookie, which we could then do everything else we wanted on the back. So you can see it's kind of nasty. Saba's going to tell you what's actually going on in web app security at the moment.
So who here knows at least one website that has cross-site scripting right now? Okay. So the rest of you, cross-site scripting is just one of the big web application security flaws, but it turns out it's really big. So Dan, can you pull up xss.com? So if you don't know of a website that has cross-site scripting right now, you can actually look it up. We have this website, xssed.com.
So we're going to check on the wireless network now.
So some of the stats show that about 80% of web applications have this issue today, having cross-site scripting down. So chances are websites that you know and use today also have the same problem. Okay, your 1 second. Yes, go there. Sure.
When it comes to session cookies, you know, XSS and session cookies, what's the correlation between those two?
You know, your session cookie is the thing that basically identifies you with the website once you're logged in, right? So your session, you look it up on the web server, and it holds all your data. Your session is stored in a cookie. So I can use.
If I log out,
You log out. Your
the session cookies no longer good?
Should be invalidated.
Shouldn't be, but it's on the server side.
Well, all the cookie data is stored on the server side, but the cookie is stored in a cookie on your browser. That cookie on your browser will probably last until you close your browser session, or there might be some other timeout, but the cookie will still be there, but it should be invalidated on the server side unless they did something stupid.
Okay, isn't that what the basis of that XSS is?
Yeah, maybe you can just explain what cross-site scripting is.
We'll get there in a second if you just want to finish
Yeah,
this
so this is xss.com. Basically, you can see up here we have archives of any sites that are publicly disclosed cross-site scripting vulnerabilities. What Dan's clicked on right now is
That's fine.
governmental or more important sites. So you can see there's Harvard, Stanford, mysql.com, Jackass World, government websites, right? So these are all known cross-site scripting vulnerabilities. You can actually see the mirror on the right side here. So they've actually done a mirror of the vulnerability as well, so you can go. So here, what they've done here is actually embedded an iframe with Google in the website. You can do a search by page rank. Please scroll up here. This is the top page rank. So what are some of the top page rank websites you think? Yahoo. So these are all the known Yahoo cross-site scripting vulnerabilities.
Wow.
All the known MSN, I believe, will follow, yeah. YouTube. And they're not fixed. You see the little X? So it's everywhere, right?
MySpace.
MySpace? Oh yeah, that's a big one.
Wow. I wouldn't have thought.
Thanks to our friend Samuel.
Who would have thought?
Yeah, so, it seems like the situation is getting worse and worse when it comes to cross-site scripting, SQL injection, web application vulnerabilities altogether. This year, for the first time, if anyone's heard of CVE, it's a Common Vulnerability and Exposures Database. So it's a database of all the publicly disclosed vulnerabilities and applications out there. And web app exploits for the first time actually outnumber the number of buffer overflows. So up to now, all the focus was going towards buffer overflows and some of the network layer attacks. Now the focus is towards the web applications. So SQL injection and cross-site scripting, we'll get into it in a little bit, but here's an example of how bad SQL injection can be, right? Somebody can just drop a full table. What does XP command shell do? Anyone know? Yeah, absolutely. Give you a command shell, give you full access, right? Yes, sir.
So the common statistic we'll see these days is that about 85% of web applications are vulnerable to cross-site scripting, and something like 40% are vulnerable to SQL injection. So it's fairly prevalent. Most developers don't know how to fix it, which makes it even more interesting. So what is cross-site scripting? Cross-site scripting, you're basically telling the browser to do something that the original developer didn't intend. You could be popping up a pop-up box, or as Travis showed yesterday, we can replace whole chunks of a website by manipulating the JavaScript DOM. So a lot of cross-site scripting is done through JavaScript. And the thing with JavaScript is it has full access to everything in the browser. It can modify the DOM, it can add stuff in, it can take stuff out, right? So people can get your document cookies, they can connect to external servers and send your cookies over there. They can load up other servers, so they can pretty much do anything. And anyone here have a website that serves PDFs? No, that's good. Acrobat Reader was actually cross-site scriptable. So any website that served a PDF at the end of last year was cross-site scriptable by using this Acrobat plugin. They wouldn't parse out a string on the end or something. So cross-site scripting can be fairly simple, right? It could be a simple matter of stealing your cookie and sending it to some location. It then shows up in someone's log file. They can now log into the website as you because they have your cookie. Cross-site scripting basically comes in two flavors, reflected or stored. If it's reflected, it's going to be reflected straight back into your browser. And you might not see anything, like in the example we did for IBD Bank, that was using reflected cross-site scripting. There was nothing stored on the server in that case. The other one is saved or stored cross-site scripting, so it's getting written into a database. It's going to show up for another user, so I can steal Saba's cookie instead of stealing my own. Currently, XSS, which we're going to talk about here in a minute, can deal with reflected. It doesn't deal with stored at the moment. We want to add stored. Stored just holds some technical problems because then you have to either know every page the vulnerability can show up on, or you have to crawl the whole site. So we haven't got it added in yet, but we're definitely looking at it. It's on the table to get added.
So did that answer your question about cross-site scripting?
Yeah, pretty much.
Okay, so stealing cookies and sessions is one of the things you can do with cross-site scripting.
Couldn't the data bank or the site that you're in the server, when you log out, if you log out and delete cookies, then you would no longer be.
Yeah, that should be the case, unless they don't invalidate the session on their side. So if someone gains access to your cookie, they can still use it.
Yeah, even if you delete it out of your browser, if they have a copy of the cookie, they can still use it.
Yeah, absolutely. If they steal the cookie, it doesn't matter whether you're still holding it or not, they can use that.
Yeah, the worst box you can ever check is remember me.
Oh, yeah.
Don't remember.
The thing you'll often see with sessions is that they'll either not have a timeout, or the timeout will be ridiculously long.
Yeah.
And if you steal my session, what's the first thing you're going to do? Make sure it doesn't time out, right? You're going to ping the site every 4 hours. So your session should have a maximum time from creation to end. Well, that was creative.
Yeah, so typically we'll see idle timeout, and you see 15 minutes to 30 minutes, but you rarely see that hard timeout. So if what Dan was saying was if somebody catches your cookie or your session, they're not going to let it idly time out, right? They're just going to keep pinging the website. So what we recommend is that kind of hard timeout, saying why would anybody be in my application for more than 2 hours, right? So you time it out right after 2 hours.
My laptop hates me, in case you're wondering. So the other thing that's making this whole cross-site scripting thing more, have you ever seen Ajax? Anyone seen an Ajax application? Yeah? Ajax pretty much lets you do what you want on the browser. So we can load up more pages, it can replace stuff in the DOM, right? So we can do all these things. The thing Ajax does is it can send data, it can receive data, and it can parse data. So suddenly you can use Ajax requests to run your whole cross-site scripting attack, and you can script this thing. That's exactly what happened at IBD Bank. There's an iframe that loads up, it's full of Ajax goodness, and it runs the cross-site scripting vulnerability against the bank and steals all my money. So the other benefit of this is, of course, it lets you avoid anti-censorship tokens, like I mentioned. So the changing technologies that are coming out these days in web applications are making these simple vulnerabilities suddenly a lot more dangerous. It's a lot easier to do these things because of stuff that's showing up. There are actually a few good tools that Sab was going to mention here that are available for doing this testing.
So does anyone here use web app scanning tools? Yes, a few people. Okay, which tools do you use? WebScale, yeah, that's a popular one. So there's quite a few open source tools, right? OWASP WebScale is a pretty popular one. You can probably use Peros, right, to do some web app testing. You use Fiddler. Burp. There's quite a few. I mean, I can't think. Tamper Data is another one, right, that we just use. So, there's a lot of open source tools, and then we have our commercial tools, right? And those are really cheap, right?
Oh, yeah.
How much do those go for? What do you guys?
$170,000 license typically, and some of them are outrageous.
Yeah.
Some to do like binary code review,
Mhm.
binary code analysis. So
Like
those are
analysis,
like-
yeah.
In fact, some of those are subscription only, which means that we rate them every time you submit the code to the camera.
For every time you're
Yeah.
doing a scan, yeah. So it depends. There's enterprise-wide licenses and it's per use. Some web app scanning tools, probably cost you about 35,000 to 50,000, depending on the size of the enterprise, how many people are using it. So, it becomes very expensive. And secondly, sometimes they're a little, I guess, what we don't consider them very lightweight, right? So they're heavyweight. There's a lot going on, right? We may not want it for every single thing that it does. We may want something very specific. Sometimes we have QA that need to test the application, and they don't, they may not necessarily be the most technically savvy people, right? So if they're using Web Scarab, they have to know about the details of HTTP and how to manipulate parameters and whatnot. So what we're really looking for here is a tool that is very lightweight, right? Does exactly what we want it to do, and point and click, right? Easy to get. So what we're finding is, and we do a lot of training for developers and QA personnel, what we're finding is that developers aren't using any of these open tools. They're not using Web Scarab. They're not testing their application because, first of all, it's not convenient for them, right? They have to start up this secondary service, and obviously time is always a factor when it comes to development. So, and we do want them to use it in SDLC though. So there's a few places in SDLC that we were targeting when we wanted to create a tool. We said somebody in development should be able to run this against their code, right? So before actually pushing it out to test, it should be easy enough that they can verify, do unit testing. And once it gets to testing phase, QA should be able to also use the same tool. And post-production, we as consultants going in and doing a test in post-production, we should be able to use that same tool. So we wanted a tool that simple enough that people of varying technical skills can use it and is very light. And of course, again, this isn't a business case presentation, but see this little hockey stick over here, right? It's your classic time versus cost, but it's much more steep than usual, right? What you see here, sorry, too quick. Yeah. What you can see here is, if we can have developers actually run this against their tool and find one vulnerability in here within the development phase, we're saving, I think it turns out to be about 1,000 times the cost to fix something in production and in code. So the business case is there. We won't really get into it. So Dan, is there any hope?
Yeah. This is where cross-site scripting comes in. I'm going to put this thing down. It must be terrible. I told you I was going to make terrible noises. So I'll just talk really loud because he has the thing. So let's take a quick look at cross-site scripting. If you were here last night, you would have seen Travis's demo where he went to the bank, the Altamiro Bank, which is a test site for us. So we're not doing this on actual someone's data. Although I do like to run it against Google.
I've been doing that all day.
I've now joined the group of being molested by
Now, is there a... It doesn't fit. Thank you, Vic.
So, if you were here last night, you would have seen the demo that Travis did.
Hey, I have some stuff in the car that might help that problem.
Almost got it. There.
Where he cross-site scripted the Altamiro Bank. So we're actually going to use XSSP to find that same vulnerability. So if we open it up here, it's actually fairly simple. You can see there's one form on this page, search form at the top, and that's where we already know that it's cross-site scriptable, but this is cross-site script, and we're just going to run the top set of attacks, which I'll explain those in a minute, against this website. So it goes off and it starts firing off all these tabs and starts doing stuff in the background. There's actually a nice little counter here. So it's looking for cross-site scripting vulnerabilities, and then it's using what it's sort of found on the page to run certain scripts against it. And we end up with this. So what's this telling us? Right now, we can send any of these characters against the text field, and we'll explain why we care about that when we get to the heuristic testing in a minute. It's something we've done for speed. When we look at this, we can see there's one cross-site scripting failure. So there's one thing we know is exploitable. There's 3 warnings, so 3 things that are possibly cross-site scriptable depending on your browser and user actions. And we'll get into that in a minute. What makes a difference? So we can come down here and we can see that into the text search, if you put in something like script, and we're using document vulnerable so the tool can tell what's going on, but some JavaScript into the search script field, into the search box at the top, it will come back as cross-site scriptable. So right away we can see quickly and simply where the cross-site scripting vulnerabilities in which field, in which form, based on a web page.
This is your tool?
Yes. This is cross-site scripting, yes.
Doesn't that vulnerability change like every day?
That's a good one.
Yeah,
It's a very good one.
but that's what gets into the features of cross-site scripting. If you've ever heard of arsenic, cross-site scripting comes with the full, well, almost the full list of arsenic's vulnerabilities for cross-site scripting. We took in a couple because we realized they were referencing back to our website for external cross-site scripting where it pulls up a script, and people kind of get paranoid when you do that. So we took those out and made them a separate add-on that you can pull off our website. You can get the JavaScript if you want to put it on your own website. You don't have to reference ours to let us know you're using the tool. Yeah, that was a fun one. But
Does this search for the newer ones, like Billy Cunningham just released a book about encoding JavaScript cross-site scripting attack in white space?
we'll get to encoding.
Stuff like that.
We don't deal with encoding at the moment.
Okay.
We want to do encoding, but it's a matter of how much time we have to put towards these things. And what's most common out there right now is
It's better than nothing.
exactly. So let's take a look at the options we have with this thing. And if you download this off our website right now, it's not going to look like this. I'm actually using the release candidate for the new version, sort of an internal one. So you're seeing the new stuff.
It's due to be released in a couple of weeks, so you guys should have it soon.
So we have a few options we can use when we're doing this. We can do the preferred number of attacks to test. That's the number that will run if we do this top attacks thing. So typically you might not want to run all, I think there's 180 strings in there right now, because it takes a while. So you can say, okay, these are my 5 favorite attacks, and they cover most of the things I see, and you can just set that number and it will run 5 attacks. So you can quickly do some scanning on things instead of doing the full list, which can take a while. The number of tabs, you saw the tabs whipping up in the top there as it ran. It uses the tabs to do all of the processing. The more tabs you open, the faster it's going to run, the more memory it's going to take. So you can sort of pick for yourself if you want to not be able to use your laptop for a while and set that number really high, or you can set it low and keep doing what you want to do. I've got it on 5 because it works. You can see we've got heuristic testing enabled, and Saba will tell us what that means in a minute. And these are the special characters we're actually checking for heuristic testing. So we're looking for those characters specifically, and you can ignore the other stuff because it's just internal stuff. And the other more important one is the strings. So this list of strings here is basically Arsenate's list of vulnerable attack strings. So we've gone through and added it to the system. So you can move things up and down the list if you want for the ones you find more important. You can add your own, and you can let you put your own little signature in so that if you wanted to submit this to us to put it in a future version of the tool, you can have your name attached to it. You don't have to do that, it's blank. You can remove, if you don't like this one for some reason, you can remove it. You can export this whole list if you want to change things or do something else with it. You get an XML file of it and upload another XML file. So you can change these lists as you need. You can customize it to your environment depending on what you're doing. So the whole point is to make the tool more customizable and useful for people. So, let me get my phone back here. So that's that part. And
Does it work for hidden form fields?
yeah, oh yeah. He knows my part of the presentation better than I do. So yeah,
Sales
this,
guy. So,
this isn't just the form fields you're seeing when you look at it, right? This is everything. So we've actually got a little video here. This is a program called AppFuse. I believe it's a Java program that lets you easily launch other Java applications, which is actually cross-site scriptable in one of its hidden form fields by default. So we can see we're just coming in here, open up the test application, and it's the username field or something. So again, open up cross-site scripting, and it's the ID field. So we can actually go into the ID field and tell it to only check that one field because we don't want to test everything. You just want to test a specific field. Well, the top 9 attacks against that one field instead of running everything. And this is what the old version looked like. You can see it's different. It doesn't give you as much information as it runs. It goes off and does its thing, and it'll eventually spit us back a report telling us how AppFuse did. We can see there's 3 filters, so there's 3 different strings in that top line list that it's vulnerable to. And you can go down and see what the value was that it submitted. It even tells you at the top what all the other values it used when it submits, so that you can go and replicate this again on your own and see how it happened. And then you can go and fix it. So you can tell your developers, if I put that value in this field with these other values, it breaks. You can tell them exactly how to fix it, and they can go off and do their thing.
They're a par, it's approved. The manager decides it's cost effective.
Okay, it takes 3 weeks to get there.
So then we move on to heuristic testing.
Yeah, heuristic testing. So you saw there was an option in there saying if you want to do heuristic testing or not. That's actually a feature of the new version that's coming out. So we realized that, let's say you have a page with 10 fields, and we have about 100 attack strings, right? That's 1,000 tabs it has to open, right? So we thought, every time we find a cross-site scripting vulnerability, usually it's just one field within that form. It's not all of them. So what we do now is, before running any of the tests, what we do is we say, for every field that is on that form, check if any of these characters will be unencoded when they're displayed. So we first try a semicolon, and we see the reply, and if the reply doesn't encode the semicolon, we say that's a possibility that there may be cross-site scripting here. So we flag that field, and we say we're going to test that. So that's what you see up here, is what you're seeing is that for that one field at the very top, which is a text search, every single one of those characters came back unencoded. Whereas in the unnamed field, they actually were all encoded when they came back to us. So we didn't bother testing the second field. Because really the basic premise behind cross-site scripting is that you send text and it comes back in the exact same way you sent it. And you can actually include some malicious characters. So now with heuristic testing, it really speeds things up. So we usually have 1 or 2 fields that we test instead of the entire form. Okay, so how does cross-site scripting, or how does this tool really work behind the scenes? We knew that when you're testing it manually, you're looking for a few things, right? You send an attack string, and you really wait and see if the script gets executed when it comes back. And it was very easy to see if the script's being executed because, you do a pop-up box or change something on the form, and you can visually see it. Well, how do we get an automated program to recognize that? So how can we get it to recognize that the script's executed? Well, what we made was this document.vulnerable DOM object. Cross-site script me, what it does is it sets it to false before any testing. And once the page comes back, so if you can actually just pull up all the list of the attacks, maybe. So you can see most of our attacks, if you can see that, all they really are is some sort of variation of the script which says document.vulnerable to true. So if we look at our rendered page when it comes back and document.vulnerable is true, we know that the script executed. And that's really how it works in a, behind the scenes, where we make sure that every single script has this vulnerable equal to true, and that, I guess, signifies that there's something wrong. Now, there was a few cases, and we noticed early on that there's a few cases that may not be caught by this, and there's a good reason for that. There's certain scripts that are executed in some browsers and not others. So we wanted to make sure our tool catches those as well. Dan can pull up one of them. Yeah, so apparently certain versions of IE, and I think Netscape, actually allow you to define your own form types, HTML elements, and you can give it a certain attribute that will be executed no matter what. However, Firefox will not render that. So Firefox won't render a tag by the name of XSS, but IE would. So what we said was, okay, what we'll do instead is run 2 tests. So the first is a rendered request. So we'll send it across, and if the script executes, we say possibility of a cross-site scripting vulnerability. Now, if the second one also comes back, and we just look at the raw request before it's rendered, and we say, is the script there? We don't care if it executes, does it come back in the exact same way we sent it? If the two are both true, that's a red flag. That's when you say this is 100% a cross-site scripting vulnerability. Whereas if one or the other is true, that's the yellow flags that you saw earlier in that version. So what that meant was something came back, maybe it wasn't rendered, but the exact same text came back to us.
The other place where this also comes in handy is you can have cross-site scripting vulnerabilities that only happen, say, on mouse over. So you can inject it on mouse over into a tag, so only when the user mouses over that will it become vulnerable, so it won't execute in the browser when it's initially loaded. So we need the second test to find those kind of on mouse over attacks. So thank $D80 for structs, right? If you're a developer or someone tells you use structs and it will save all of your problems. Sure, you can use structs, and it's a good idea to use a framework, but just don't follow their examples because they're cross-site scriptable. So they ship with these nice examples when you install structs. It's the structs examples. We can go look at the upload example here. And by default, the text at the top here is actually cross-site scriptable. So using something like a structs framework isn't going to save you when you do this. You have to be doing input encoding, output encoding. You need a sort of defense in depth strategy here to defend yourself against these things. So I'm guessing if they had run some kind of tool like SSSMe against their demos here, they wouldn't have a vulnerability by default in the structs examples. And these are what people are going to be using to write their web applications, right? So this is precisely why 75% of our web applications are vulnerable to cross-site scripting, because our examples are vulnerable to cross-site scripting.
World runs on copy and paste code.
Yeah.
That's right.
Okay. Where am I now?
SQL injection.
Yeah.
Okay, so that was one of the big kind of web app attacks, right? SQL injection, who's heard of it? Who hasn't heard of it? Who doesn't want to put their hand up? Okay, so SQL injection it's really the same concept. You take input, you don't validate it, and you somehow, this time, instead of displaying it back to a user, you include it in a piece of SQL. So what that does is it allows the user to modify the SQL. So in this example here, we're taking the username and password from the user. The user enters Jimmy as a username, and as their password, they enter blah or what equals 1. So what this does is behind the scenes, we've allowed the user to modify our SQL. Does anyone know what the SQL does, the statement? Select star from users where username is Jimmy and password equals blah.
So someone said it always returns true. Right.
Always returns true.
Right.
Yeah, so the or 1 equals 1 at the end, which the user has somehow manipulated the SQL to add or 1 equals 1, makes sure that this statement is always true. Even if they didn't know Jimmy's password, all of a sudden every row in the table is returned. So bypassing authentication. Right?
The other trick you can do with this is if the SQL is set up such that it won't evaluate to true, you can actually change username and comment out the rest of the job or the SQL. So you can change what the thing says completely to whatever you want. You can reject your SQL statements.
Yeah, so imagine as your username, you have put Jimmy hyphen hyphen. Does anyone know what dash dash is in SQL?
MySQL, yeah.
Yeah, so what that means is what you've done is said select star from users where username is Jimmy, forget about the rest. Right? So you no longer need to know the password. That's really the big danger of SQL injection. You can obviously do much more. This is an example of just bypassing authentication. You can drop tables, you can obviously run command line. So how do we fix it? Well, it turns out the solution is not only more secure, but it's faster. So it's best to use prepared statements. In the last slide, we saw what we're doing is we're tacking on our username and password onto the statement. That's called dynamic SQL. So what we can do instead is create prepared statements where we can differentiate the difference between user input and actual SQL statement. So they can't modify it. Or stored procedures work the same way. Except you can go wrong in stored procedures by using the exec command. So if you are using stored procedures, you can still do cross-site scripting for SQL injectable.
The problem here being developers don't know to use prepared statements. Developers think, okay, this is quick, easy, nothing can go wrong, or Jimmy over there has validated this on the front end, so I don't have to worry about it. They don't really think about prepared statements, so they just do dynamic because it's easy. And then they get SQL injected. So for that scenario, we have SQL injecting, which is the second tool we released in our Lightning series. Come over here, close XSS me. We'll go back to the same multi-row bank. I was playing with this last night. I found that the login form here is SQL injectable. Anyone know this quick and easiest way to search for SQL injection?
Use a single quote.
Exactly. Just stick a single quote in there, and if the thing crashes, you're probably good to go.
Why is that though?
Oh, well, yeah.
You create a false or bad syntax in your SQL statement.
So we can take this and we can run SQL injecting. You can see here it's actually showing up two forms. So there's two forms on this page. So you can search multiple forms depending on how many you have on your page. You can do all of them, or you can just pick specific fields off specific forms, which is what I'm going to do now, because I happen to know that field is SQL injectable. So I'm going to run the top 9 attacks against the password field. And it goes off and it opens up its million tabs and runs its little box. So we can see that there's 3 failures. The interesting thing about this is the one string that I know it is susceptible to for SQL injection shows up as a pass. And the reason it does that is because we don't know your web application. So specifically for SQL inject me, you actually have to go and do a little bit of upfront work to get it completely correct. Because if you look at the bank here, I can go to the bank and type in A, and then A tick, or I can't type, 1 equals, I'll type it in the other one so I don't have to see it. 4, 1 equals 1, right? So this is actually valid because I can log in. And SQL inject me by default will pick that up. Oh, we did that earlier. So I can also crash the application by doing it too. So it's a very good application.
When you crash an application like that, does it actually kill? It doesn't kill like the SQL process or anything.
No, it's the Java. It's just throwing an exception, so it's not actually dead. It's just for some reason I can no longer type. Or
One more question. If you can crash an app like that, can I crash your app like that?
okay, if I could ever actually log into this thing correctly, you would say it says hello whoever. So the thing is, I can then take the fact that there's a specific string on that page after login, and I can go into SQL inject me through the options up here. It's similar to cross-site script main. It has this list of SQL injections. So I can find my 1 or 1 equals 1, which I know it's susceptible to, and I can change the list of things it's looking for. So by default, it looks for database errors. And one of the developers just went through and added like 6,000 output error strings to this thing yesterday. I don't have that version, but I can come and modify it and say, okay, if you see hello, this is SQL injectable based on whichever one I just clicked on, right? So if you see any of those output error strings, you've got a problem.
Yes.
So you're not able to test any kind of blind injection where like a web application, some web applications will not output any errors. Right?
Yeah, we can't test for that. So we need some way to check in the web page that there is an error.
There are SQL functions that will delay the query, like timing functions. So if you were able to inject one of those and then tell that there was a delay of like say a few seconds or let's say 5 seconds.
Yeah, like a
It's a
time
good
is-
idea, and if I get your email later, I can hook you up with the developer and you can explain it to him.
I know in like my Microsoft SQL Server there's functions like that. I don't know about
Oracle too.
SQL.
Right.
Yeah,
And that's-
specific.
That's a good idea. And the one thing with these tools is these tools are open source. So we like people's feedback to tell us better ways to do these things. Like the first version didn't have heuristic testing, and it was just too slow. So we've gone back in and we revamped them based on this user feedback to make these things better. Because we want people to use them, because we want people's web applications to be safer.
So you're saying the way you can detect SQL injection vulnerability is by trying to inject a delay into the database and
It would
judging
be
when it comes back?
dependent on the database management system. But there are functions out there that will have a delay, so you can detect the delay.
How long it took for it to come back? Yeah, that's a good one.
We also use yes/no response questions based on the return query after yes no response.
Yes, no response as in.
You add like a and 1 equal 1 versus a and 1 equal 0, and look at the response pages that come back. They can come back differently. You can use that as a blind injection technique.
Yeah, absolutely. Yeah, that's a good point. And the thing is, you can, right now what we're really doing is just looking for, we're saying if the page returns anything, right, and that's configurable. So it's configurable enough you can actually add that in yourself.
And just so you don't think we're screwing around again, SQL injection. Anyone here use Daffodil CRM? No? Good. Daffodil CRM is an open source security program that is by default cross-site scriptable on the admin page. They've known about this for well over a year, and as far as we know, they don't care to fix it. So think about your CRM solution, which anyone can log into over the internet through a simple SQL injection by making up your admin password, basically. They've now got all your customer data, probably emails, everything else, right? And this is a common open source web application that just nobody's fixing because nobody cares.
And now we do too.
Yes. So that's the thing. There's a lot of these that are out there that developers don't understand, so developers won't fix it. So you can see that there's 9 failures just on the login page for Daffodil CRM. So features for SQL injecting, they're actually quite similar to XSSME. They're basically the same code base, which is like a minor fork. I'll go into the thing here. Options. So we can see that it's basically the same, right? How many number tags we want to run, how many tags we're using. There's no heuristic testing for SQL injection at this point. I don't know if I've ever actually had anything like that. It's pretty quick. And then it's the list of attacks we want to run and possible result strings. So same as the other one, they're exportable, importable. You can move them up and down the list. You can add, remove. Same as that XSSME. So that's the main part of this. The next question you might have is, if I move my thing so you can actually see it, where can you get these from? They're available off our website, securityhubs.com. They're not on the Mozilla extension thing. But you can download them off securityhubs.com. The extra SQL injecting attack strings, cross-site scripting attack strings are also available there. These are open source, GPL version 3, so you can get the source code. We welcome patches.
Wait, you mean we're not making any money off this?
We welcome patches, comments, ideas, plugs. If you think we're stupid, let us know. We want the feedback. And if you try to run Firefox 3, we know it doesn't work. Their Firefox 3 changed their APIs so much that we need to redo the program. We thought it was more important to make it faster and better before we bothered to port something that isn't released yet. So if you try it in Firefox 3, it's going to crash. I can tell you that now. And so what do we have coming up? Well, you've seen some features of what's going to be in version 3, which comes out in a couple months, I think.
More within a month.
Yeah. We want to add auto-encoding, so you can do fix canonicalization issues in web applications, like sending in Chinese versions of these characters. We want to add that in. We haven't got to it yet because there's other stuff we wanted to do first. And we have other tools sort of in the Exploit Me series where we like Forget Me Not. We're doing username enumeration off forgot password pages, and then brute force me to brute force people's passwords once you find them out. So there's a whole series of these tools that we're sort of thinking would be kind of cool and really handy for us to have as pen testers to play with.
Just one more thing to add, as a limitation of cross-site scripting and SQL injecting, they're only testing form fields, so you can't test parameters in the URL or parameters through cookies, and that's something that's also coming out in future versions.
Yes.
What part of Canada are you from originally?
Toronto. Well, I'm not actually from Toronto. I'm from Owen Sound.
Okay.
All right.
Questions?
I guess that's it. Any
Yeah.
questions?
So on the rendered request versus the raw request, you said if it's red, it means both true.
If it's red, it means that it can either mean that they're both true or the rendered was true. Because if the rendered's true, we know what happened.
Okay,
Okay, so it's really if rendered was true.
Yeah, it'll be a warning if the rendered is false, but the raw is true. It may be injectable, we don't know. So we give that as a warning. But if we render it and it happens, we know that it happens, right? It doesn't happen.
So the raw comes back. So what cases do you have a raw with no render?
On mouse over. Say you're using an on mouse over attack.
You want to do a demo?
Okay.
Yeah, you can type it in.
Check time. Yeah, I'll show you guys what we mean by the on mouse over.
We don't need to discover I can't type, so we'll let him type.
Okay, so this is an example of a site that's not vulnerable, but okay, so we'll do a Google search for whatever. Okay, so as you can see, our actual search string, it gets redisplayed in the box, right? So imagine if I had done something like this. On mouse over. Does anyone know what the on mouse over event does? When you mouse over it, so basically what would happen is if this field had an on mouse over event attached to it, when I hover over it, it would execute. So let's say I submit this as my query. So what I enter gets redisplayed to me, right? Now, I said this is an example of a site that doesn't have it, and it's because Google, so I'm going to do a quick source. Okay, so here's the source of our page. Not the title, no, the title. So you can tell my search query shows up in a few places, but there's one specific place I'm looking for. Okay, here it is. So you can tell that Google encoded my double quote, right? Now imagine they hadn't, right? If we had actually done this, I can't use it now, but imagine this was a double quote showing up here. What that has allowed me to do is enter an on mouse over event onto that field. So the next time I hover over the field is when the script executes. So the script doesn't execute on its own. However, if Google hadn't done this encoding, right now it would have allowed me to enter a script into the form field. Right? And the results would only be seen when the user does something such as hover over it. So our rendering case catches the case where the script executes right away on its own. The second case is when it may not execute on its own, but it could execute based on something the user does. So, yes?
So if it's not renderable, it still may be cross-site scriptable. In fact, it probably is, because you can do things like override. JavaScript is pretty OO, so that means you can overload or override objects that are native in the language.
Yeah.
So even if you're not showing the attack, odds are, if you can get it on the page, you're attacking something. So I wouldn't even say warning. I'd say there's still cross-site scriptable. It's still,
Yeah.
it still sucks.
Yeah, I think so.
You still fail as a developer.
Yeah, it's really true.
And it's also up in the air because it's only certain browsers in some cases. Like the XSS tag only renders in IE6, 7, and Netscape 8.
That's the JavaScript standard. You can override any JavaScript object on any browser.
So, there you go.
Yeah, it's pretty dangerous actually.
So yeah, so there are cases where we have to do both tests in order to determine it, and this is one of them. I wish I had a real example for you, but I couldn't. I could find one. I just didn't want to exploit a real website in front of everybody. So, if you really like to try, go on xss.com, and I'm sure you'll find it.
Especially on camera.
Yeah.
Just be careful. We've had people moved out of here before, so.
Okay. Okay, any questions?
One more.
Yes.
So, with the SQL injecting, I guess if you knew what a successful login would look like, I guess you could kind of use that as a brute forcer instead of looking for SQL injection. Say, here I found a SQL injection. I just want to put in a bunch of usernames, passwords. If it works, then can you use it as that or not?
Yeah, you could. What you have to do is modify the list of attacks that you're going to carry out, and there could be some possible passwords that you think you have. And as the thing to look for, right now we have errors that we're looking for, but you can change that to, as Dan mentioned, the word welcome. If you see the word welcome, you know you've logged in. So it's configurable enough to do that as well. Yes?
Also, since you're using an application that pretty many people know about, if I open a server and realize that that application is being used, can I lock you up into the black hole and send you into a loop that never is?
Well, we don't recommend you run this on any application that isn't your own, and you're not testing your own application.
From a defensive perspective, could you set some sort of honeypot to look for these types of attacks and screw with people?
Sure. Yeah.
And you could do it on a live system, right? Analyze the logs in real time and say, you know, this particular IP address is obviously brute forcing me or signal ejecting me. So I'm going to rewrite my PS rules or firewall rules of choice to null route this guy or send him over to a machine I don't care about.
Yeah. Actually, Google, when we were testing this tool on, we tested it on Google, I think, once, and basically they give you a CAPTCHA after a while. They give you a CAPTCHA image to make sure you can't do it.
That was in response to a worm that was harvesting email addresses off of Google. If you fire off too many Google searches at Google, they figure out, they just finally say, oh, you're clearly some type of program, I'm going to try to slow you down.
I've done that before.
Yeah,
It's all
there's a form passing.